I'm Luxmary, Associate Professor in the Department of Computer Science and Engineering, Mohini College of Engineering Technology. The subject code I'm going to take is CS8088, the wireless. So the core objective is to understand the IEEE 802.15.04 ZIGBEE protocol in wireless. So no standard approach today that addresses the unique needs of most remote monitoring and control application. It enables the broad-based deployment of reliable wireless networks with low complexity, low-cost solutions. It provides the ability to run for years on inexpensive primary batteries for a typical monitoring application, capable of inexpensively supporting robust mesh network. So how ZIGBEE is related to IEEE 802.15.4? It takes the full advantages of physical radio and MAC layers that is specified by IEEE 802.15.4 low layers. ZIGBEE adds logical network, security and application software for higher layers. ZIGBEE continuously to work closely with the IEEE to ensure that an integrated and complete solution. Applications of ZIGBEE, so security, lighting control and access control, then environmentally energy management, then consumer electronics, PC and peripherals, residential light, commercial access control, lawn and garden irrigation. 2.15.4 ZIGBEE in concept. So ZIGBEE Alliance, we will be having IEEE, the customer, the hardware, physical and media access control layers. An application physical will be having 868 MHz, 915 MHz, 2.4 GHz. So the stack will be stack and application. Stack will be having API, security, as well as network. Network you can have star network, mesh network, and cluster free network. Security you can have 32-bit, 64-bit, or 128-bit encryption based upon your need. Then application. Basic network characteristics: 65,000 2 power 16, so 64, so 65,536 network lines. It can support optimized for timing critical applications. Network join time 30 minutes. That is typical. Sleeping slave is changed to active 15 minutes. Active slave channel access time 15 minutes. The network coordinator. So network coordinator, it has a full function node. So these are the reduced function node. The communication for a reduced function mode will be different. The virtual links is connected to the network coordinator. So why is ZIGBEE? ZIGBEE is reliable and self-healing. It supports large number of nodes, easy to deploy. When deploying, a very long battery life is secure, low cost, can be used globally. So the architecture looks like this. So we will be having a physical layer, MAC layer, then a logical link layer, other logical link layer, and application. So the physical overview, operating frequency bands, the channels 2.4 GHz, 2.4 GHz to 2.4835 GHz. The channels may be 11 to 26, depends upon the need. The channel is 0 to 10 channels. It operates at various. So preamble 32 bits. It's for used for synchronization. Start of the packet delimiter is 8 bits. Physical header is 8 bits. Packet protocol data length, sequence data, source data length, source data length unit. Then this will be up to 2016 bits data field. So data service, physical data, exchange data packets between MAC layer and physical layer. Physical management service, clear channel assessment, energy deduction. Then you can get and set retrieve, set physical PIB parameters, enable or disable 64-bit to 16-bit. Ultimate the network size is 2 per 16, that is 65,536. 3 devices are specified: network coordinator, full function device, reduced function device. Simple frame architecture, reliable delivery of data, association disassociation. AES, asynchronous advanced encryption system. Then CSMA is for 128 bit. CSMA is CA access. Collisions carries its multiple access with collision avoidance. Optical super frame structure with beacons. Optimal G device classes. Full function device or else any topology network coordinator capable tags to any other device. Reduced function device RFD limited to star topology, cannot adapt mesh and other topology, cannot become a network coordinator, talks only to the network coordinator. Then a very simple star mesh and cluster T. So each and everything will have the pan coordinator, it will access the cluster, then full function no, and the reduced master slave, full function device and the mesh topology, full function device and the cluster tree. So for example, the cluster nodes exist between the rooms of a hotel. The room has a star network for control. Pan coordinator, they can have so many number of clusters. This is called as pan coordinator. This other cluster head, the device is connected to this. Can have the cluster of tree of network key attributes, simplicity, low cost, longer battery life, single point of failure. This has 64-bit IEEE addresses. Short addresses can be allocated. Addressing modes, network and device identifier, source or destination. Types of MAC frames: data frame, acknowledgement frame, MAC frame, beacon frame. So only two most basic structures is in 802.15.4 provides up to 104 byte data preload capacity, data sequence numbering to ensure that the packets are tracked. Robust structure improves reception in difficult conditions. Frame sequence check. Frame check sequence validate error-free data. Preamble start of delimiter. Acknowledgement frame format. The other most important structure for 15.4 provides active feedback from receiver to sender. That packet was received without error. Short packet that takes advantage of standard specified quiet time immediately after data packet transmission. Physical protocol data unit PPDU. The physical preamble start of delimiter. MAC layer protocol data unit. The frame control, the sequence number, frame check sequence. And frame button. So mechanism for remote control and configuration of client nodes allows a centralized network manager to configure the individual clients to matter how large the network. So the protocol physical layer of source of protocol data unit is 12 plus 4 to 20 plus n. Frame format, if it's add a new level of functionality, client devices can wake up only when a beacon is to be broadcast, listen for the devices, and if not heard, return to sleep. Beacons are important for mesh and cluster networks to keep all of the networks nodes synchronized without requiring nodes to consume precise battery energy listening for long period of time. So overall, so MAC data service and originated, it's a request. So the originator MAC, the channel access, the data from will be sent. Recipient MAC, it will give the acknowledgement. Then the MCPS data indication to the recipient. The originator, the data is sent. The beacon mode. The beacon mode is slotted carrier sends multiple access and with collision avoidance. So coordinator between the coordinator and the node, coordinator send the beacon, the node will send the data frame, the acknowledgement will be sent the data to the coordinator. The nodes are synchronized with the coordinator. Here the node and the coordinator and the node, beacon, data request, acknowledgement, data frame, then acknowledgement, data from the data to the coordinator will not have the data request. Acknowledgement is a request. Here the data from the coordinator will have the Network layer function, starting a network able to establish a new connection, joining or leaving, it's because of members. Then the configuration, ability of the node to configure its stack to operate its accordance with the network type. So addressing the ability of a ZIGBEE coordinator to assign addresses to devices joining the network. Synchronization, ability of a node to synchronize with another node by listening for beacons or polling for data. Security, ability to ensure end-to-end integrity of frames. Routing, it's a properly route frames to the destination AOD. Support layer functions. It maintains what the device is capable of doing and makes a binding request based on their capabilities. Discovery, ability to determine which other devices are operating in the operating space of this device. Binding, ability to match two or more devices together based on their services and the name, needs, and allow them to communicate. Switch and lamp. Source layer 0.10. The destination is P1.0. So 9.0 will be having EP 2.10. These are the binding tables coordinated. It's created by the end user. The endpoint is a sub. Sorry, I explain about IEEE 802.15.4 ZIGBEE protocol for wireless sensor network. Thank you.